All right, so we're going to talk about rational exponents. Rational exponents. What rational exponents are, okay, rational number fraction. Okay, so basically we have fractions in the exponent value. So for example, okay, so if we have x to the power of 2, okay, that's technically a rational exponent. It's x to 2 over 1. We also can look at what's called x to the 1/2 power, right? X to the 1/2 power. Okay, those are rational exponents. And what we're going to look at is we're going to look at, well, how does this work? Okay, x to the second, x to the 1/2. Well, what does that mean? And so we're going to look at this in this point. So x squared, basically means we have x times x. Well, x to the 1/2, well, how do I have half of an x? So what this means is your denominator is your root, okay? Your numerator is your power, okay? So your numerator is your power, your denominator is your root, okay? And so what I mean is we're getting into the square root. So x to the 1/2 power is the square root of x raised to the power of 1, okay? So square root raised to the power of 1. That's x to the 1/2 power. Well, with a square root, when we have a 2 there, we don't have to put the 2, so we just put it as that. That means square root. To the power of 1, remember, anything to the power of 1 is itself, so why are we going to write it? So that's why x to the 1/2 power is just basically the square root of x. All right, so if we look at that, so let's go 4 to the 1/2 power. 4 to the 1/2 power is the same thing as the square root of 4. Well, square root of 4, okay, square root of 4 is what times itself is going to give us 4. The square root of 4 is 2. Okay. So let's look at another one. All right, let's move my little picture here of me. We don't need to look at that. So if we have 8 to the 1/3 power, okay, that's the cubed root of 8 raised to the power of 1. Well, the cube root of 8 is what times itself 3 times gives us 8. Well, that answer is 2, because 2, if we look it out, 2 times 2 times 2. Okay, we have 3 2's. Okay, 2 times 2 is 4. 4 times 2 is 8. Boom. So with square roots, I always think of them as kind of like the number underneath the root's the answer. We need to figure out the problem. It's kind of like Jeopardy. All right. So let's take a look now here. What if I have 9 to the 2/3 power? Nope, I got that backwards. Sorry, I wrote that down backwards. Let me fix that. 9 to the 3/2 power. Okay. What that means is, again, my denominator is my root. So we have the square root of 9. And my numerator is the power. So raised to the 3rd power. Okay. So order of operations, let's do the parentheses first. Well, what's the square root of 9? What times itself gives us 9? Well, that would be 3. So we have 3 to the 3rd power. And then 3 to the 3rd power is 3 times 3 times 3. Well, 3 times 3 is 9. 9 times 3 is 27. Okay. So 9 to the 3/2 power is just 27. Okay. So let's look at, like, what if I have the square root of x to the 4th? Okay. If I have square root of x to the 4th, anytime I have a square root and I have an even number exponent, I just cut it in half. Okay. So the square root of x to the 4th is just x to the 2nd power. Because square root, I'm just taking 4 is an even number, I cut it in half. Okay, half of 4 is 2. So the square root of x to the 4th is just x squared. Look at another. Square root of x to the 10th. The square root of x to the 10th, 10th is an even number. So I'm going to cut 10 in half. So it's x to the 5th. It's a funny 5. Let me erase that. Oh, there's our answer. Well, what if I didn't have an even one? Well, let's do the square root of a to the 9th power. Okay. Well, 9's not even. So I know some of you are going to go, oh, well, I can still cut 9.5. It's 4.5. No. What we're going to do is we're going to rewrite this. We're going to rewrite this as the square root of a to the 8th times a to the 1st, right? Because when we multiply, we add. 8 plus 1 is 9. So these are the same thing. Well, now I have the square root of a to the 8th times the square root of a. Well, now I have that even number. A to the 8th would be a to the 4th. Well, a to the square root of a to the 1st, I can't do that. So I'm just going to rewrite it. Okay. So the square root of a to the 9th is a to the 4th times the square root of a. We're just breaking things down. We could do the same thing with numbers. So let me get a different color. Let's make things colorful on here. All right, let's do the square root of 12. Well, what times itself can give you 12? I know I go 6 times 2. No, it's not asking what times 2. We're asking what times itself gives you 12. Well, there's nothing. Well, now we need to think, okay, is there any perfect powers that do? Well, let's go through real quick. All right. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. So that means if we do the opposite, so the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. So if I were you, I would write down this list so that you have it. These are all perfect roots. Okay. So then we need to figure out, okay, well, what are factors of 12 that are perfect roots? And I always like to go through, well, okay. So let's see here, 12 divided by 1. Yeah, I can do that. 12 divided by 1 is 12. That doesn't help. Well, what's 12 divided by 4? 3. Ooh, so I can split up this into the square root of 4 times 3. What's now can be rewritten as the square root of 4 times the square root of 3. Well, the square root of 4, we know right here, square root of 4 is 2. We don't know the square root of 3, so it's just 2 root 3. So the square root of 12 is just 2 root 3. Let's do another one. What if I asked you the square root of 24? No, let's do a different one. Let's do, because that's going to kind of be the same thing. Let's do let's do the square root of, let's go 45. Square root of 45. Well, let's go through. Okay. 45 divided by 1. Well, that's 45. Okay, there's 45 divided by 4. No, that can't be done. Okay, 45 divided by 9. 45 divided by 9. Oh, that's 5. So we're going to split this up into square root of 9 times 5, which is the square root of 9 times the square root of 5. Well, the square root of 9, we look over here, 9, 3. Okay, so 3 root 5. So we can split things up like that. Now let's expand to the next part. What if I gave you this problem here? Let's go with, let's go 16x to the 6th. If I wanted the square root of 16x to the 6th, well, first I'm going to, is 16 a perfect root? Let's go back to my list. There's 16. Oh, it's 4. Okay, so I can take the square root of 16 is 4. Ooh, x to the 6th power. That's an even number, so I'm going to cut it in half. So it's just, so the square root of 16x to the 6th is just 4x cubed. Okay. All right, so let's do another one. Let's get a purple pen here. The square root of 8x to the 4th. All right, well, let's see here. 8. Is 8 one of my perfect roots? Nope, it's not. Well, now let's go through. 8 divided by 1, well, that's 8. Okay. 8 divided by 4. Ooh, I can do that 4. So let's split up 8 into 4 times 2, x to the 4th. Right? Well, the square root of 4 is 2. Square root of 2, nope, we're going to leave that there. Square root of x to the 4th, that's even, so we're going to cut it in half. So it's 2x squared. That's done, that's done. Up, I'm just left with the square root of 2. So the square root of 8x to the 4th is just 2x squared times square root of 2. Right? Another way you can look at this is the same thing. If I would have told you 8x to the 4th raised to the 1/2 power, these two things are equivalent. So let's say I gave you this problem right here, 8x to the 4th to the 1/2 power, right? Say I gave you this problem. Well, I would just rewrite it as the square root of 8x to the 4th, and then I'd go through my steps. Okay, let's look at one more problem on this stuff. So let's go the square root of 18y to the 5th. Well, let's look real quick on our list. 18 is not a perfect root. Okay, so let's do 18 divided by 1. Well, it's 18. Okay, that doesn't help me. 18 divided by 4. Nope, can't do that. 18 divided by 9. Ooh, I can do that one. So we're going to split 18 into 9 times 2. All right, so we got y to the 5th. Ooh, that's an odd number. So I need to rewrite it as y to the 4th times y to the 1st. Okay. And now I just go through. Square root of 9 is 3, so that's done. Square root of 2, nope, can't do that. Square root of y to the 4th is just y squared, so that's done. Nope, can't do so. Now I'm just left over with 2y. So square root of 18y to the 5th is 3y squared, root 2y. That's it. All right, let's go with, all right, next thing we're going to talk about is multiplying roots. Okay, so we're going to talk about multiplying roots. I don't know, let's change that to a 5. If I have the square root of 3 times the square root of 5, I get to multiply anything under the root. So square root of 3 times square root of 5 is just the square root of 15. Because they both have a root, I get to multiply what's underneath. Now, what if I had this? Square root of 3 times the square root of 5 minus 4. Okay. Well, now we have a nice, wonderful property, SpongeBob's favorite property, my favorite property, the distributed property. We had the square root of 3 times square root of 5. Well, we just did that right here. That's square root of 15. Well, now we got the square root of 3 times negative 4. Let's just like, if we distributed an x, we would take x times 4, which would give us 4x. Same thing here. So it'd be minus 4 root 3. Oh, we're done. Now, what if I gave you something like this? Let's go with so 2 root 5 plus root 3 times, let's go with, let's go root 7 minus root 3. Actually, let's go. Minus 3 root 3. Okay. Well, now we have the wonderful world of the double distribution, also known as the FOIL. So we're going to take 2 root 5 and we're going to multiply it to root 7. We're going to take 2 root 5 and we're going to multiply it by 3 root 3. So 2 root 5 times root 7 is going to be 2, and 5 times 7 is 35. So 2 root 35. Then we need to take 2 root 5 times negative 3 root 3. So we're minus 2 times 3 is 6. Root 5 times root 3 is root 15. Then this is where things get tricky. And like I said, it's double distribution. I need to take root 3 to here, and I need to take root 3 to here. So root 3 times root 7 would be plus root 21. Root 3 times this would be -3 square root of 9. We look here, okay, is there anything I can, oh, square root of 9, that's a perfect root. So I can rewrite this as 2 root 35 minus 6 root 15 plus root 21 minus 3 times the root 9 is 3 times 3. So now I have 2 root 35 minus 6 root 15 plus root 21. 3 times 3 is 9 minus 9. And we're done. That's it. Okay. Now, one of the things I want you to recognize, let's say I have, let's go root 10 plus 5 root 10. These are the same roots, so I can combine them together. 1 root 10 plus 5 root 10 is 6 root 10. Okay. So when you distribute or you're multiplying roots, take the outsides, you can multiply together. You take in the roots and you multiply them together. And then when you're done, you combine like terms, just like you combine like terms with simplifying expressions. All right, so the next thing we're going to talk about, again, dealing with exponents, is we're going to deal with exponential, a little bit more with exponential notation and setting exponents equal to each other, right? Two x equals 2 squared. So if I have this, 2x equals 2 squared, if my bases are the same, see how the base is the same, they both are at 2, then our exponents equal each other. So my bases are the same, they both are at 2, so that means my x equals 2, which makes sense, because if x equals 2, 2 squared equals 2 squared. Those are the same thing, right? Correct. Okay. So now, what if I had this? 2x plus 1 equals 2 squared. Well, if we look here, my base is the same, they both are at 2. My bases are the same, then my exponents equal each other. So we have x plus 1 equals 2. And then we have a 2-step equation. Well, a simple 1-step equation. So now we have a basic 1-step equation. X plus 1 equals 2. Well, I know how to solve this. Minus 1, x equals 1. And again, if I plug that back in, 1 plus 1 is 2. 2 squared equals 2 squared. So again, when our bases are the same, we can set our exponents equal to each other. Well, sometimes our bases aren't the same. So what if I had something like this? Let's get a different color here. What if I had 2x minus 1 equals, let's go 4 to the power of x? Well, my bases aren't the same. So that means I can't do anything? No, not necessarily. See if there's a way you can make your bases the same. Meaning, look at the bigger one, the 4. Is there a way I can turn 4 so that it has a base of 2? Well, yeah, because 2 squared is 4. So I'm going to rewrite this as 2x minus 1 equals 4 is 2 to the power of 2. And then I'm going to put my exponent with it too. Now, if you look, we have the same basis. They both have 2. So that means our exponents equal each other. So we have x minus 1 equals 2x. Well, now we have an equation with variables on both sides. We know how to solve this. So we're going to get our x. So we're subtract x. Negative 1 equals, well, x. Oh. So there we go. There's our answer. So again, when you have something like this, you can set your bases equal to each other so you can then solve them. So, for example, do another example here. What if I gave you something like so? 9x plus 3 equals 81 x minus 4. All right, our bases are not the same. Bases are not the same, so I'm going to look at the bigger of the bases, so 81, and I'm going to see if there's a way I can turn 81 to be a base of 9. Okay, so meaning, is there a way I can make it as 9 to the second power, 9 to the third power, 9 to the fourth power, whatever. So let's start, okay? 9 to the first. Well, 9 to the first is 9. 9 to the second power. Ooh, that's 81. So I'm going to rewrite this. 9x plus 3 equals 81 is 9 to the second power. And then I'm going to put in parentheses x minus 4. Now we have the same bases, so we're going to set our exponents equal to each other. So we got x plus 3 equals 2 times x minus 4. Hey, look, we know how to solve these. Distribute the 2. X plus 3 equals 2x minus 8. Subtract x, subtract x. 3 equals x minus 8. Add 8, add 8. 11 equals x. Boom. We're done. So that's how you solve these. Do one more that you might see. So if say, all right, let's go with, we have 3 to the 2x minus 3 equals 27. Right? So we're like, wait a second, this doesn't have a base. Well, if you remember, we look back here, okay, we can still rewrite things so that they have a base. Okay? So how can I make 27 so that it has a base of 3? So let's just run through. What's 3 to the first power? 3 to the first power is 3. All right, what's 3 to the second power? 3 to the second power, 3 times 3 is 9. Okay, no. 3 to the third power, 3 times 3 is 9. 9 times 3 is 20. Yeah, so let's rewrite this as 3, 2x minus 3 equals, well, 27 is 3 to the third power. Now we have the same base, so our exponents equal each other. So 2x minus 3 equals 3. So we're going to add 3, add 3. 2x equals 6, divide by 2, divide by 2, x equals 3. Boom. We're done. So we can even plug that back in, okay, to x. 2 times 3 is 6. 6 minus 3 is 3. So we have 3 to the third power. Yep, boom, we're good. Okay. So that's how you do these. All right. This is the tangram stuff. The previous stuff is what you're going to see on the worksheet. On the worksheet, 9, 10, 11, and 12, you can ignore. I did not go over conjugates. I will go over those with you guys when I get back on Tuesday. But you should be able to do everything else on there. There's a little bit of review in the beginning part. And then there's just simplifying these stuff. You don't have to work in order. You can work in different things. So there you go. Hopefully you can get your work done. And good luck and thank you for watching.